A particle travels along a circular path of radius a. So we have a circular path. Say this is the starting point. And this is of radius a. It begins at point A, so we'll call it as point A. It moves clockwise, so clock is, this is clock, right? Yeah, this is clockwise. It begins at point A and moves clockwise. Calculate the displacement, magnitude, and the distance traveled by the particle as it moves from A to B. So we'll call this as B. And it moves from B to D. We'll call this as, I don't know if this was supposed to be D or this is D. Let's consider this as D. And moves from D to B. Oh, it's moving in clockwise. Okay, let's have this itself. So let me make this as D. I think this will be a better scenario. I mean, that's also a good question. I don't know why I feel putting D over here will make it a bit more confusing. Nicer to discuss. That's what I meant. Okay, so we have two aspects. So we will start off with A. It moves from A to B. Now, what is the distance? Distance is quite simple. Just follow the path. What path should we follow? This is 90 degrees. So this is 1/4 of the circumference of the circle. I'm not going to write the detail. I'm not going to treat you guys as ninth graders. So this is 2 pi r, right? The actual path that is. So this is basically pi by 2 into A, or pi by whatever you want to represent it as. So many units. So that's your distance in this case. While the displacement will be displacement will be a straight line connecting the start to the end. So this is A, this is A, this length is, yes, Pythagoras theorem, so 2 root of A. Right? Or A, sorry, no, not 2 root of A or A root 2, yeah. So many units. Similarly, when it moved from P to D, same thing actually. B to D, everything is the same. Think about it. B to D, we are moving 1/4 of a circle, and it's a straight line connecting from B to D. And then we have movement from D to B in clockwise direction, guys. Clockwise direction. So what's happening over here? Distance will be how much? 3/4 of the circumference. So this will be 3 pi A by 2. While the displacement will be what? D to B will be same as P to D. So displacement will be the same. As simple as that. Displacement will be A root 2 unit. I forgot to write units. Units. Then what else? Yeah, that's it. Okay, I just have one more question to you guys. What is the displacement when the object moves from A to D? I'll write that over here. When the object moves from A to D. So this distance will be, look at the distance, A to D. It's the semi-perimeter. While the displacement will be what? It's a straight line connecting the starting point to the ending point. So what is this straight line? This is a diameter. So this says how much? 2A. Okay, Yeah. So it's a simple question. If an object moves from point O to point A and then to B, find the distance traveled and the displacement. Yeah, please pause and try it. Okay, so in this case, the distance would be, first it moved from 0 to A, right? I need to add that distance, line segment basically, and then A to O, and from O to B. I just need to add the length, that's it. So in this case, it would be 13 plus 13 again, and then plus 15. I don't care about rect. 43, right? 6, 13, 15, 15, 2, 4, 41. Yeah, 41. Right. 41 and unit is meters. You guys are big enough. You are grown up, and you should not be missing units. While the displacement will be what? Displacement it all has to do with where it started off with. It started off from O and where it ended up and where it is as of now. It's at minus 15. So minus 15 meters. Indicating that negative sign indicates that it's to the left, since the direction is of concern to us. So straight line connecting O to B is this length, 15, but in the negative direction, that is to the left for us as of now. So we consider right as positive. So obviously left, since it's one dimensional motion, left is negative. So you can indicate the directional aspect as well.